Hi there and welcome to this tutorial for the Strider plugin in Unreal Engine 4. In this tutorial we're going to finish off by creating a animation system for a character. Now we're not going to do a fully final AAA product ready animation graph, but I'm going to show you how you can integrate a lot of the Strider nodes into what is closer to what you would want to use in a game. Previously we've just been looking at every node and all its features and how to set it up, but that's not always practical for your game. You need to know how to put it in the graph, where to put it in. Now it's going to be a little bit different to what you'd probably expect from a normal graph. However, if you're familiar with Paragon's animation system, that's a game made by Epic in the past, then you're gonna probably be pretty familiar with what I'm gonna do here. So first things first, we've got our basic third person template. I've made this ramp just for testing. And before we get started, just make sure you've got the plugin installed. Again, if you haven't seen all the previous videos, go watch those. It shows you how to set it up and exactly what every node is. This tutorial is going to be largely unscripted as I'm going to go through and create a character basically, but just make sure your Strider is enabled. And I'm also using the animation starter pack, so I've got a few more animations to play with in this demo. Now, the first thing I'm going to do is I'm actually just going to convert this basic character to the skeleton for these animation starter pack. I'm not going to bother with retargeting and all that. I'm just going to convert it over completely. So I'll go to my character blueprint and I'm going to change the mesh. And I'll change it to the second one, and I'll set the animation blueprint soon. I'm going to go to this folder called Strider tutorial, which I just made for this tutorial. I'm going to make an animation blueprint, and I believe I need to use the second skeleton. And I'm going to call this ABP under Strider tutorial. Name it whatever you like, and we'll go in there and let's just set up something really basic to get started with. Now I'm going to create a state machine. So add new state machine. We could plug it into there, but for now I'm just going to plug cache the pose, and we're going to call this locomotion pose, and we'll just call the state machine SM locomotion, and then we're just going to use cache pose locomotion. All right, just to keep it simple. Now in our state machine, we're going to start with just 2 states. We can add more later, but in 2 states is going to be enough to pretty much show you everything I want to show you. We might add a few more later just to cover some extra details. So we're going to have an idle and a run transition between the two. Now we're going to need 2 variables to start with. First variable is going to be is accelerating. Now this is different to is moving, because is accelerating we're going to get from the character movement component. So if the player is not purposefully moving the character with input, and if it's like falling, or if it's being pushed by physics or something, then it's not going to register is accelerating. Whereas if you think about is moving, if you get the velocity, it is going to register it. So we don't want that. Next we're going to just add the speed, because we're going to use this variable a fair bit. And we're probably going to add in a ton of variables, to be honest, but we'll start with just this. So basic transitions. So we'll transition to run when accelerating is true. And we transition back to idle when accelerating is not true. Accelerating is false. Alright, so that's a basic setup. In our idle, let's just add one animation to each of these so we can see something on screen. So idle, rifle, hit, plug that in, move on to our run state, and we'll go idle, jog, forward rifle, plug that in, we'll compile, and our animation seems to be working fine. I'll save that, and we'll go to our third person character, to our mesh, and we want to change that animation class over to, what did I call it? I called it ABP Strider tutorial. And there we go, that's working now. So when we play, we should have that animation, but of course we aren't doing anything in our event graph to trigger the run state. So let's do that quickly. Go to our blueprint, animation blueprint, and we'll go to the event graph. First thing I'm going to do here is we're just going to check if this is valid, because we don't want to do anything if it's not valid. Next thing we want to go to do is we're going to get the speed. So let's say get velocity from the pawn owner, and from the velocity we're going to get length. Sorry, vector length. And so only if it's valid, we'll just stop there. If it's not valid, we're going to set the speed. Not get speed, set speed. Okay, so we set the speed. Now we could do something like just set is accelerating if the speed is greater than 0, but we don't want to do that. We're going to actually get the acceleration. So let's do that. So we're going to say cast to character, and as character a get movement component. So I believe we can just go from here and we'll say get acceleration, get current acceleration. There we go, delete that. And we can get the vector length. We'll check if it's greater than 0. I actually might like to make it greater than something like 0.001. Just so we don't get any floating point inaccuracies. And then we will set is accelerating, and we'll chuck that in there. So we've got our two things here basically. Sorry, I need to connect this up properly. This actually needs to go into here. So we'll separate this out. So set is accelerating. Set speed. And all that. Now, just keep in mind that all the stuff I'm doing here is not necessarily best practice. I'm just throwing things together as a minimum so that I can show you how to use the Strider nodes. This isn't going to be a production ready thing, so just keep that in mind. This is not best practices. I'm not caching things like the character and the character movement. I'm not doing all that stuff. So make sure you think about your own performance when you're setting up this graph, but you'll get the idea from watching this. So let's go back to our map, and here we go, our character moves around. Now it's pretty much the same as it was before. We basically remade the third person character with a different skeleton and stuff like that. But let's change it so that it's a bit more strafey. Let's go to our character, and on the character movement component, we want to go down to rotation. Orient rotation to movement, check that off, and use controller desired rotation. So the controller desired rotation is going to be set by the way the camera is looking. So we want to strafe, always facing forward with the camera in this particular case. So orient, we don't want to orient rotation to movement, and we want to rotate to where the controller is, which is the character. So now we have this strafing movement. We're always facing forward. Of course, it looks awful because we're just running forward, but we're about to fix that. We're going to use the orientation warping node first to do all that work for us. So let's go into our state machine, and we'll leave idle. We'll go to run. Now, we don't want to have like run forward, run left, run back states. We're going to set them all up within this single state. And the way we're going to do that is using a BlendPoseByInt. Now you could make a custom enum for this, but the integer is basically going to be a cardinal direction from 0 to 3, 0 being north, and then going clockwise up to 3. So we're going to actually need a new variable for this. So let's add this as a integer. Now again, you should probably make an enum so this makes sense, but I'm using an integer because, I don't know, I'm lazy. Cardinal direction. And we'll plug that in here, get cardinal direction. I'm just going to chuck that there so it's on top. And we're gonna need 4 slots on this one. So we right click and we go add blend pin, and we'll add 2 more. I'm gonna set the blend time to around 0.2. This is really up to testing. And I'm gonna output the pose there. Now, what we need is we need all 3 of our clips. So we got jog forward, jog left, jog right, and jog backward is the 3rd one. So going clockwise, forward, right, back, left. All right. Now, obviously you can do your own logistics for how you want this to work, but these are basically all gonna plug in like this. And before we add in any strider nodes, so we're not even at the strider nodes yet, we're going to have to set these cardinal directions. So there's a few things we're going to need this. We're going to need to actually keep track of the relative direction. So this is the direction, the difference between the way we're facing and the way we're going. So let's make a variable called relative direction. And we'll give that a float. So this is just going to be an angle in degrees, going clockwise, forward being 0, you know, all that. And we're going to use that relative rotation to set the cardinal direction. So let's go to our event graph and first calculate the relative direction. So here's our event graph. We need to now calculate this relative direction. We need to set that somehow. So we're going to do this only if the character is moving, because we need the velocity, right? So if we don't have any velocity, it's not going to give us a meaningful direction. It's going to start jittering around. So let's first do that. We're going to make a branch, and we're going to say if we could even just use that there, but I'll just say get is accelerating. So if we are accelerating, we are going to then set the relative direction. Now, you would go through and you would get the velocity vector and you would do all that. However, I have made a utility function that comes with Strider, and it's in the Blueprint function library. And to save time, I'm going to use that. You can use that. You can do it yourself in Blueprint if you want. I prefer to, keep a lot of math functions just in Blueprint in C++, just because it's less messy for me. So it's called get rotation relative to velocity, and you can see it's under this title animation warping utility. So that's where most of the utility functions from Strider are. So it's pretty simple there, and we'll throw in the actor, and let me just get that so it's not so annoying, and then we can just set it. So that just makes it way simpler. You don't have to have too many nodes. So that's going to give you our relative direction. And the same thing for the cardinal direction we need to then set is another function. So under animation warping utility, we've got to set calculate get next cardinal direction. Now you could apply your own logic to it. This function is just a single example. You could have even a component for your character that's calculating this based on your own logic. However, I've made this function which is also quite simple. It takes in a bunch of information, your current cardinal direction, your relative rotation. So let's get the current cardinal direction, get cardinal direction, and we can throw in our relative direction there that we just calculated. And it then decides which cardinal direction it needs to switch to based on that relative direction and based on the cardinal direction you're already going. Now there's two things. You can go to the next in either direction. So if you're going forward, which is cardinal direction north or 0, you could either go to the right after a certain amount, or you could go to the left, or you could go backward. So there's a step delta. So the step delta is to the left or to the right, and then there's a skip delta, which is skip. So if your relative direction is basically greater than 60 here, it's going to go to the next one, left or right. If it's greater than 135 degrees, it's going to just skip to the back one. So yeah, as I said, this is just a function for doing the logic for calculating your cardinal direction. You can do it any way you want. You can do it in Blueprint if you want. When I did it in Blueprint, it took up so much space. It was frustrating, so I just made this function. And it's just much easier and much cleaner. So there we go. I'm going to leave the step delta at 60. Actually, I'm going to make it 70 and the skip delta at 135. So once that direction gets too far, we're going to switch the cardinal direction so we're not twisting the character too much. So this should now work. Let me just check my state machine. So we're not going to twist, obviously, but it is going to switch between the animations, and let's have a look at that. So now you can see that instead of just running straight all the time, it does switch between the cardinal directions. Now this is really important because this is now the basis that we need for orientation warping. Obviously, we're only getting forward, back, left, and right. We want to have all the in-betweens here. And that's what we're going to use orientation warping for. So back to our thing here, and let's create a bunch of orientation warping nodes. Orientation, where is this? So animation warping, and we're going to orientation warp, and I'm going to plug that in. Now I'm not going to create the others because I'm going to copy this with the same settings. So the root bone we need to set. Again, if you haven't done this before, then go back and check the other tutorials. I'm not going to go into detail on setting this all up. So here's the spine chain. I'm only going to do it the spine. I'm not going to do all the way to the head because we're aiming a gun. We don't want the gun's aiming to change. We still want that to be forward. So I've set up the spine. I'm going to keep their weights as 1. We'll have -1 smoothing, so no smoothing for now. We'll start with that. And this max warp delta I'll explain later. It doesn't really matter, but basically you'll set that to whatever is your minimum for the cardinal direction change. Back to our event graph, so whatever you've chucked in here, basically, you're going to want to have as the maximum. Yeah, it just means that when we're switching states or flipping between different ones, it's not going to freak out. Alright, so we'll compile that. And that seems to be all set. So we've also got this offset, and that is going to be different for each one, and I'll show you that in a sec. So let's copy and paste this 4 times. Okay, and we'll plug all of those in. And we're also going to get our direction vector, so our relative direction, get direction, and we're going to plug that in to each one. Same relative direction for each. But what's going to be different about each one is they're going to have a different offset. So if you think about it, your run forward is already orientation warping 0. Your run right is already orientation warping 90. So you need to offset that from our relative rotation. So it's going to be the opposite. So our jog right is a 90 degree to the right. So we need to offset that -90 degrees. So now we'll put this one as -90 degrees. We'll put the jog backwards as, it could be 180 or -180. So let's just say -180 because we're going clockwise. And the left will just say its offset is 90 because, running left is -90 degrees. So we're offsetting all of those like that. So there we have our animation warping set up. It should be all good to go with those offsets. Let's hit play and have a look. Okay, so now you can see when I do a diagonal, we're getting all the in-betweens there. And of course I'm using a keyboard, but if I use a gamepad, you'll probably notice we can get much smoother in-betweens here. And already our character is just miles ahead. We've only used one node and our character is already miles ahead of that default, and it didn't really take that long. All you need to know is a little bit of know-how. Now you might want to, as I said before, you might want to make your own logic, because for example this is kind of weird. 70 degrees from your back left. So you might want in different cardinal directions, you might want to have different ranges, whereas my function only lets you set ranges, one set of ranges for all of them. So that's just where you might want to do your own custom thing there. I'm fine with this for demonstration purposes, but yeah, you get the idea. So let's take this a step further and use the orientation warping, because of course the character seems to, you know, move at the same pace even though I'm going slow here. So I'm only pushing a little bit on the stick, but the character's still running, you know, the feet sliding like crazy. And if I was able to like sprint, you know, you wouldn't see that. So let's go ahead and set up the stride warping node now, so that we can get a bit more diversity in our animation with regard to speed, especially when we're using a controller. Okay, back to our animation graph, and we're gonna have a few more variables again. So we're gonna have our stride scale. So that's how much we're gonna scale the stride. However, it's best to combine a little bit of play rate change and stride scale to get the best effect. But you want to cap your play rate change because you don't want to go more than like 10-20% tops on your play rate changes for speed. Because when you do speed up when you're moving, you do move faster, but not that much. You take bigger steps. So it's a combination of the two. So we're going to use a combination of play rate and stride warping. So there's the stride scale, and we also then need the play rate. And we're going to set these up in the event graph a bit later. So, sorry, not a boolean, that's still a float. So we'll say play rate. Okay. And I'm going to expose the play rate on each one of these. And we're going to chuck in the play rate. We're going to set the default to 1. I've got to compile first. And we'll chuck that in there, get play rate. Because what will happen is if we use play rate completely, when we're moving really slow with our gamepad stick, the character's going to actually freeze and can't move, which means you can't turn either, and that's not a good thing. So we've chucked that all in there. And then the next thing we're going to do is set up the stride warp node. So stride warp. So warp, animation warping. The reason it's not coming up is because I'm dragging from a local pose, whereas the stride warp node uses a component space pose. So stride warp, there we go. And it'll just convert it when we plug that in. So that's all good. And we'll plug that back out. Okay, our graph is starting to look pretty decent here. We'll get our stride scale. We'll plug that in. Now, because we're also orientation warping, we're going to want to change the direction that the stride is being scaled upon. By default, it's going to be scaled in the forward direction, which isn't necessarily good if we're running right. So we're going to expose the direction pin, and we're going to plug in our relative direction here as well. So it's going to be scaling the stride in the correct direction, the same direction that we're orientation warping. Let's set up all the stuff in here really quickly. So I'm going to set the root to the pelvis and project to ground. Offset we shall leave. Smoothing, we can leave all of that for now. We'll just make it instant. Let's set the hips to the pelvis. Adjustment ratio for running is probably going to be something like 0.5. We'll leave all those other settings for now. And I'm going to add 2 limbs. The first is going to be the left leg, so the tip is going to be your foot L, and the IK target is going to be IK foot L. The tip here is going to be foot R, and the IK target is going to be foot R, IK foot R. And they've both got 2 bones in them, so that is good. We can leave that there. That should all be set up and should work correctly now. It's not going to work quite yet though, because we need IK. We haven't set up any IK in our graph. You'll probably have a look. See, if I change the stride, let's simulate something here. Let's say is accelerating in speed. If I change the stride, we're not going to see anything happen. We do see it adjust the hips, but we don't see it adjust the feet. If we look at the bones, bones, you can see the IK bones are being scaled out. sorry, not speed, scale, and scaled in. But we have to actually set up an IK node so that that's going to work. So let's do that. Let's go to our animation graph and let's add in some leg IK at the end. So leg IK, actually again, it's a component space pose. We'll plug that in at the very end and we'll plug that in there. Now this is actually where our slope warp node is going to go eventually. So let's do this. Let's set this up. We have 2 leg definitions, and this is a similar setup to the stride warp node. We want to have foot L. Sorry, this is the IK first. IK foot L, and then the FK foot bone, which is the actual foot L, and then we go to the next one, and we'll say IK foot L. This isn't a tutorial, obviously, about how to set up IK. Just keep in mind, you know, I'm not going to change any of these other default settings. You can do that if you like. I'm just going to use the defaults for quick demonstration. Compile. All right, so you're going to notice straight away that it kind of messes up. And I think I actually got a reference wrong. I went foot L and I did both L. So IK foot R. You're going to notice that it actually changes your idle pose, and that's because this animation set doesn't have the IK targets animated with your base animation, which you probably should have in the first place. It doesn't matter though, we're just going to use the stride warp node to set those positions anyway. You'll see if I go to accelerating, and my stride scale should actually be 1. You can see the stride warp node is actually putting them in the right place for us. So we're going to just cheat a little bit and chuck in a stride warp node in the idle, just so that we can fix that for now. But it's a bit silly, and we're just gonna have a scale of 1 all the time, and then that should fix that idle issue. There we go. For now, that's definitely not something you want to do. You want to have those set in another way, or just part of the animation. Okay, so now this should be working. If I go accelerating, I need to change the default of stride scale to 1 because that makes more sense. Okay, so scaling, let's accelerate. There we go, we can see it's going. It's a bit janky. Let's change some of the settings. Hip adjustment, let's set it to 0. I feel like with running, you don't really move your hips down much. So it's accelerating, stride warping. Maybe a little bit, 0.2. We'll set a recovery rate. No, we won't set a recovery rate. That's basically if the hips get pulled down by the stride warping node, that's how fast it's going to recover. It's to stop that jankiness. So for example, if I set this to 1, let's set the stride scale. So see how it comes up really abruptly? So if we smooth that out, what's a good value? So let's say 10. That might be too slow. We'll find out. I'm going to set this accelerating to default as well, just so that we can test easier for now. See how it doesn't come up so abruptly? That might be a bit too smooth. So the higher the number, the faster it's going to affect it. Stride scale, maybe like 50 or 100 or something. 100 units. There we go. It smoothed out that jankiness there. So 0.5, it's going to only pull the hips down half the way. Now for a walk type animation, you're going to want to have full pelvis adjustment, because when you walk, your character actually does dip down. But that's looking a lot smoother now. So I'm happy with that. We can use that. Now we've set up our graph here. And if we go to idle, just checking, yep, it works fine. We've set up our graph here, but we haven't set any way of finding out what this stride scale is. So let's go to our event graph and calculate that. Our event graph is getting bigger by the second, but that's fine because, you know, a complex animation system needs information to run on. So now we're going to calculate the speed scale. Now, I think it's probably a good idea to calculate the speed scale. Actually, let's not do it. I was going to do it here where the speed was calculated originally, but let's not do that because I only want to do it when it's accelerated. We'll get the speed, get speed, Now we're going to divide it by our top speed. So what's the top speed of that animation? I don't know. I'm going to guess it's something like 600 or 450, 500. Let's just say divided by 500. Now this here is our total speed scale. So it's your current speed divided by the maximum speed of the current animation you're playing. Now you might want to extract a curve. So you might say get curve here. What is it? Get curve value. And then you might have a speed curve on your animations and you chuck that in so that it's always, you know, exact. But I'm not going to do that here. Let's just keep it simple for now. So I'm just going to say the top speed is like 500. We can actually check it. Let's go here, look at our character movement. We've got a walk speed. The walk speed is 600. So yeah, let's use 600. So this is now our total speed scale, but we need to find something else. So animation warping, and we can calculate the play rate. Now the cool thing here is, I'll plug this in. We can take in the total speed, and we can take in the play rate weight. So we're going to blend the stride scale and the play rate scale by a certain amount, yet we're still going to cap the play rate between values. So I'm going to say a minimum of 0.9 and a maximum of 1.1, maybe 1.15. Play with the number. And I'm going to blend them evenly. So we're blending play rate and stride scale evenly up to, but not beyond, our play rate, our max play rate. And then we're going to use everything else that's left over to get our desired play rate with stride scale. I hope that makes sense. It's a bit convoluted, a bit confusing. But anyway, let's first set our play rate. So set play rate. Chuck that in there. And the next thing we're going to do is set stride scale. Now, it's pretty simple. Once we have our play rate, our stride scale is just whatever is left over. So we can take our total and we simply divide it by our play rate. And that's our stride scale. So here we're setting the play rate and the stride scale. So this should work now. Now, of course, because this is coming off this chain, this is only going to be calculated if we are moving. And it's not really going to matter if we're not, because once we're not moving, we go to idle. And when we're in idle, we don't scale. So let's go to our game and let's try it out. Obviously, if I'm using the keys, we're not going to see any difference because they're analog. Let me get the gamepad and let's have a look. So now I'm pushing a little bit on the analog stick, just a tiny bit. And you can see, you probably want to limit your movement so you can't actually move this slow. But you can see now we're moving just a little bit and we've got all the in-betweens. And this is all happening on top of the orientation warping. Pretty well. Now let's add in a sprint so we can actually get beyond. So we've got like below our maximum stride, but let's add in a sprint to get beyond it. Okay, so let's now add a sprint, but we don't have a sprint animation, I hear you say. But that's okay, because we're going to use stride warping and maybe the acceleration warp node to make a sprint out of nothing. So the first thing we need to do is actually do the gameplay functionality for that. Let's go to our third person character and we're going to, actually we need to create an input because we don't have any input for this. Let's go to our inputs and create a new action map. I'm going to call it sprint and we'll just make this left shift and gamepad. Let me see, left thumbstick down. Left thumbstick down because I know that annoys everybody sprinting with thumbsticks. So that's nice. So here we're going to go event sprint and we're going to grab our character movement. And when we release, we're going to say, actually we'll drag it from here. So set max walk speed, I believe it is. There we go. And we'll do that twice. Set max walk speed. Just copy it. And so when it's pressed, we're going to set it. And when it's released, we're going to set it. So when it's pressed, we're going to go to 1,000. That's our sprint speed. I've just decided that. 600. Now, because we've set up the stride warping, it should warp the stride so that it looks like the character is actually moving that fast instead of just foot sliding. So let's chuck that in there and let's just play. Alright, of course I did set that up wrong. Left thumbstick down. I was thinking of a press, but obviously it's not. So it's left thumbstick, where is it? Left thumbstick, I lost it. Left thumbstick button. Okay, there we go. Left thumbstick button. So that should now work properly. So if I hit shift, you can see he runs faster and the stride is longer. And also the play rate is also a bit more obvious here. But we're moving faster. Well, it doesn't look too realistic, especially going backwards like that. I probably should change the range to 60 or something. You know, at least we're not getting any major foot sliding. The only foot sliding we'd be getting is because I've set the initial max speed wrong. The animation probably doesn't actually go 600. I'm just assuming that for now. You'd have to figure out your proper animation speed. So let's change a few things. First things first, I am going to change this step delta to 60 for the cardinal directions, because that running backwards sort of thing is kind of weird. I don't like that. And let's also change our stride warping node. The hip adjustment's a bit much. I feel like we should be flying through the air a bit more. So I'm going to make that 0.2 and I'll make this recovery rate 100. Let's test that quickly. Okay, so our hips are bopping less because, you know, when we run, our hips do not bop much. So now we've got all these different speeds and then sprinting as well, which is, again, combining the speed play rate change and the stride weight change. I believe I also, off camera, might have changed, yeah, I changed the max play rate to 1.1 here because 1.12 was a bit, 1.15 was a bit much, I felt. So what else can we do for the stride? Well, we can use an acceleration warping node. Now, while you could pass in the actual acceleration of your character, I like to use this for sprinting sometimes as well, just to change the animation so the character is leaning in the direction that they're sprinting. Now, if you wanted to get really complex about this, you could probably change it so that when you're sprinting, you're not strafing. You know, you can only run forward and do arcs. I'm not going to go into that. That is probably how I would set it up, but it's just extra work. The point is so that you can see how this stuff is all set up. But we are going to add in an acceleration warping node after our stride warp node. So let's chuck that in here. Now, of course, all of this is optional. You can use as many or as few of these as you like. Just, yeah. So let's add in, I'm just going to say acceleration, accel lean, and I'm going to use that as the input here. We're also going to use the direction for this one. Unfortunately, it's the exact same relative direction. We just plug that straight in. So we're leaning in the direction that we're actually going to move. So that's all good. We'll add in our spine. Now, to lean with the spine, yeah, I'm going to only do the 3 because I want it to recover by the time it gets to the... Actually, no, we're not aiming our gun while we're sprinting. So I'm going to do it all the way up to the head. And we'll add in the spine 1, spine 2, spine 3, oh no, that was 2. Then we're going to go to the neck, and the last one is the head. Okay, and we just need to change, again, go back and watch the videos if you don't understand this. I'm going to make this one 0, this one -1, -1, -1. So these bones are going to turn the opposite direction, so the head is still facing forward. the spine, the first spine bone is going to be bending downwards and leaning in the direction we want to go. Now we might have to change these settings in a bit based on our inputs, but that should work. Let's just test it in the animation graph quickly. Axle lean, yeah, we can lean forward and we can lean back, and if we change the direction, the relative direction, yeah, so we're leaning in any direction we want to go. All right, cool. So that is all set up. Let's go to our event graph and now set this axle lean. Let's just make it a full lean whenever we are sprinting. Okay, over to our event graph, we've got axle lean. We want to set that. And again, this is only going to be happening when we're actually moving, so that's fine. So the acceleration lean is going to be the speed. We're going to subtract the max speed. And that's our acceleration, that's our speed beyond our normal speed, because we don't want any of this leaning to occur unless we're sprinting. So when we're at our max speed, this is going to be 0, but I'm going to clamp this, so we'll clamp, and the minimum value is going to be 0 because we don't want a negative lean. So if we're like holding back on the stick, we don't want a negative lean. And the max, because our sprint speed is 1000, so the max is obviously 400. And I'm just going to put that in here. So this is a way that we're using the acceleration node in a not so normal way. Yes, you could actually get the acceleration, and mind you, getting the acceleration like this is not the actual acceleration. You'll find that the character will be maintaining a consistent velocity and the acceleration will still have a value. So yes, you can calculate your velocity, your acceleration from a delta velocity, and then chuck this with the acceleration node and it can, lean. But for now, we're just going to do it for a sprint. Just use it as a lean warping node, you could think of. So that is pretty much it. So acceleration lean. Now that's going to be a value between 0 and 400. So if we look at our animation graph again, we need to consider our settings on the acceleration warping node. So the maximum torso bend is going to be 30 degrees, and for each unit of XL lean, it's going to be 2 degrees. Now that's going to be too much because we've got a whole 400 range here. So I actually need to, 30 divided by 400. If I want to be at the max speed, at the max lean, it's actually going to be 0.075. And you can see how sometimes if you're not using these nodes in a normal way, it can be kind of arbitrary. So my torso bend ratio is 0.075 per unit of max XL lean. So let's give that a test now. Okay, and you can see now when I sprint, I lean in the direction I'm going. It's a bit choppy though, and quite extreme. You obviously want to tweak this to suit what you want. Maybe make it 25. Actually, no, I'll leave it at 30. I'll just change the smoothing. So the smoothing will be, let's say 300. 300 per second. No, let's make it 100. Let's try that out, see how it feels. A lot of this is just seeing how things feel. See, that's too slow. Yeah, that takes way too long. So it's actually going to be something like 300. Okay, then we've got a basic thing going on. Obviously, you want to spend more time on this and tweak it to your needs, but that's just one example of how to do it. To avoid making the video too long, because these graphs can take a long time to put together, let's just move on from that. Alright, so the next thing we need to look at is the slope warping. And that's going to be very simple because we only need to set that up in one place in our entire graph and it'll just work for everything. So let's go to our graph and we'll go to the very end, just before the leg IK. Now the slope warp node is a component space, so we can actually chuck it in between here and avoid having another conversion. So we'll say slope warp and we can chuck it in there. And let's set up all the info. Now, I'm not going to expose the slope normal and point because I'm just going to use the automatic detection that uses the capsule to detect. Now, keep in mind, this isn't like foot IK. It's not going to do raycast from the foot. It just detects the floor via the capsule. It's a simplified slope warping that's optimized. So if you have a lot of characters, it's not going to ruin your performance and it's better for slope. So stairs probably not going to work so well. But hey, what game does do stairs very well in the first place? If you want that, you're going to have to go the next step and use something specific for that. That's something that might come to Strider in the future, but for now we're just having this cheap version of slope warping. So I'm going to leave all of these as default, I believe, and let's just set up the information. So the IK root, so IK foot root is our IK root. Hip adjustment, we're going to select the pelvis. We are going to have to change this info here. You want to leave adjustment ratio for slope warping at 1, because if you don't, you're going to get hyperextension of the legs. That's something. This is more something you can move down when you're considering stride warping. It's hip adjustment to the same kind of struct. Max recovery rate. We're definitely going to want this to avoid jitter. I'm going to leave it at -1, which is instant, so you can see what I mean, why we want to have this. We're going to set up our limbs. Now, this isn't so that it can perform IK. It does all its IK adjustment by just rotating the IK root, but it needs to calculate the length of the legs to check that we're not over hyperextending. So let's add our tip, which is our foot L, our target, which is our IK foot L, foot R, and our IK foot R. Okay, that looks all good to me. Let's compile that and let's test it in here. Now what we're going to do is I'm going to press the tilde key to get the command line up and goes right anim node dot warp, and here's all our warp debugging. Just in case you didn't know, you can disable and enable certain types of nodes. So 0 is disabled, 1 is enabled, but we can also change the debug settings. So for example, I want to have a look at the debug slope warping. Now there's 3 levels of debugging, or 4 if you include auth, which is 0, but I'm going to just set it to 3 so we can see all the debugging for the slope. And just for testing purposes, I'm going to just change this to 0.5. And yeah, so it is working. So that's all well and good. Let's turn that off. Let's set that back to flat. So that should just work automatically because we have set that to automatically detect the slope. Again, if you want to have your own custom detection, you're going to have to do that yourself. But if you want per foot detection, that's another solution altogether. And maybe, no promises, maybe coming to Strider in the future. Don't count on it, is what I'm saying. So let's go into our scene. And here we have our slope warping. Something is going on here. Alright, I've set something up wrong in our animation graph here, and that would be because for the foot, the right foot, I set the IK foot root, not IK foot R. Silly me. Let's go back to our game, hit play. There we go. So those little debugs are on the same place. You can see that the blue and the green are in the same place when we're flat, and then when we're on the slope, you can see the green is the final and the blue is the original. You'll notice that the legs can be compressed, right? So as I'm turning here, obviously you'd want to set up your own turn and place system. But as I'm turning here, the legs will never extend beyond what the default of that animation is. Otherwise you kind of ruin the pose. Yes, you can extend up to a fully straight leg, but it's not great. Now, there's a few other things happening here. Let's, let me just shift F1 and eject. Have a look. So our feet are here. Are they on the ground perfectly, or is it a slight? No, they seem to be pretty flush. There is an offset that we can change if they're not perfectly flush, and that is height offset, that value there. So let's have a look at some of these other things like slope downshift rate. Let's go back to our game, and I'm gonna go to brush view. So you can see these little balls here. The blue ball is the original hip position. So if we didn't have any stride warping on, the blue is the original feet, original hips. The yellow is the first stage of hip adjustment, and then the green is the second stage. So that yellow is based on the downslope shift rate. So if we have a look in our animation graph, we've got this downslope shift rate. So that's 20 centimeters, 20 centimeters per unit of slope. So however you want to call a unit of slope, I guess it's degrees or gradient. I think actually in this case it's degrees. Actually, no, it's not degrees. It's just the gradient. So 20 centimeters. So what's going to happen is the hips are going to get shifted down the slope. Now this is to stop over compression of the front leg, because when you're going up steep slopes, it can really over compress. It also helps because it brings the hips closer to where they need to be so that the back leg doesn't hyperextend. What happens next is we shift the hips towards the back leg so that it has the desired length, so that we don't hyperextend it. So that's what this debug setting is going on here. So you'll have a look. I'll just chuck this down here so we can see a bit easier. Okay, not what I was after, but where's the downslope hip shift? So if I make this 50, you can see the hips were shifted down the slope way more. Let's make it 100 just for being over the top sake. You can see it shifted way back. Now it kind of looks silly, like it's kind of like we're glued to the ground. We've rotated the whole character, but that's too much. If we don't do it at all, you'll find the character's very far forward, and maybe you like this, and that's fine. You can do it like this if you want. That option is there if you like. A little bit of hip shift is better. Obviously, the steeper the slope, the more shift there is going to be, and that sometimes helps with over compression of the leg. So I'm going to turn on my lit, so that is basically working. I'm also going to now turn off my slope warping debug equals 0, and that will all go away. Alrighty, so that is a lot of the nodes. But you'll see one other thing, it's very jagged as we change. You'll see as we change between slopes, it's very jagged. So we need a little bit of smoothing in two different ways. We need to smooth the slope, because while, yeah, we want it to be as quick as possible to conform to the slope, we also don't want it to, jump between them. And watch what happens when we go on stairs. I did say stairs are a bit of an issue. You should probably make your stairs ramps if you're using this, or obviously use a high quality version of slope warping, so like a per foot raycast. Either way, let's smooth this out so that it looks okay. So there's two ways we can smooth it. So slope smooth rate, that's the first way. Let's set that to something like 5. We're smoothing a slope normal, so the slope, the smooth rate can be pretty low. So that does a little bit. And we want to make sure that it's not doing too slow. Because if we go, you see like that, it adjusts. I'm kind of okay with that, because I'm gonna have turn in places that are gonna fix that anyway. So we'll make it a little bit faster. I'll make it 7. The next thing we want to smooth is the hip adjustment. So you'll notice as we run over this, the hip is getting pulled down the slope, and then it's not, and then it's getting pulled down the slope. So that's very abrupt. And what we can do is we can change the recovery rate so it doesn't recover instantly. So the hips can get pushed down instantly because we must ensure that that back leg is not hyperextended. However, we can compress it a little bit, so it's okay if it takes a little bit of time for it to recover. And I like to do this instead of having some physics spring, because then you just introduce more complexity. Springs can be a bit fiddly, especially depending on frame rate. It's hard to get it to be nice and easy to adjust. So in this case, we just use like a flat rate, and it just allows it to recover at that flat rate. So let's say, I can't remember what was a good rate. Let's just try something like 20 max recovery rate, and we'll see how we go. Might be a bit slow. Okay, so see how slow it recovered at the top there? Whoop, that's way too slow. So we need a much bigger recovery rate there. Let's say probably 100 is a good, oh, whoops, that was the wrong value. That was the downslope shift rate. Max recovery rate, about 100. Let's give that a go. Now that's too fast. 50. Yeah, it's getting there. So you get the idea. You play with it as much as you want. Of course, if you reduce the amount of hip shift, you're going to need to smooth less. So say if I make the hip shift rate like 10, it's going to get adjusted down less. So you're going to get that effect less. But remember that you're always going to be adjusting for the back leg. So there is going to be some shift anyway. Now, here's a bit of a limitation that you should be aware of. As we go to a corner, we're only getting the slope from the capsule, so it's only 1 point. So it's hitting that corner and it's getting the average between those two slopes. So you're not going to get perfect per foot. Again, you're going to need to use a specific foot or wait for a potential upgrade. Or don't wait for it. Anyway, this helps going up the stairs as well, and also over this little bump. The stairs are still not fantastic. You probably want to play with your settings even a bit more, because the stairs have the same issue where it averages it out, but it goes between being very steep, very flat, very steep, very flat, because it's using that capsule. So, yeah. So we got that here. If I turn off the smooth rate here, to -1 again, we'll see as we go over this little bump, we get this doo-doop, 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 like shock absorbers almost. We want it to be a little bit more smoothed out without having the complexity of springs. So what did I have it as? I had it as like 50 or something, maybe even like 40. Either way, play with it and come up with the setting that works for you. That'll do for now. One thing to note, when you jump, the slope warping is going to be disabled. It does check the capsule when you're in the automatic mode and turn it off. But there we go, we've used most of the nodes now. I'm not going to really use a bank warping node, because bank warping is kind of something that you... Okay, let's set up a bank warping node to use with our sprinting, and we're going to pretend that we've made a new state where we're sprinting, we can't like strafe backwards and stuff. The problem is that when we're strafing backwards and we're doing all that bank warping, it's not going to look good, and our character's going to be like spinning on some weird angle. So let's just pretend, and we'll move around like this, and we'll use a yaw delta to inform the that node. I think it actually looks pretty good already, but yeah, we'll do a little bit of that stuff. Alright, onto our bank warping node. We're getting quite a lot of nodes in here. Again, use what you need, don't use it just because it's there. Alright, so we'll chuck in our bank warp node here. We'll just get this set up nice and quick, and we'll add the root bone, and we'll just do... We're sprinting, so I'm going to use the heads as well. So the idea that in this game, in this hypothetical game that I'm making, when we're sprinting, we're not aiming, so it doesn't matter if I change the direction the gun's facing. So I can rotate all the way up to the head. And you know, twisting the body doesn't affect the aim, so it's fine. if it was a problem, you probably would not do the twist part of the bank warp node. You just do the lean or something like that. So you've got to obviously think about what you're doing when you're using this. These nodes are not a be all and end all. They're a tool in the bag that you need to fit into your structure to suit your specific game, okay? It's not a, oh, just make animation button, okay? I know that seems obvious, but it needs to be said because people will still not understand that. Okay, so we're twisting the spine and we've got the root bones set up. I'm going to leave the default settings and let's add in a variable. Let's call it your delta. Let's call it your rate because we don't actually want the delta, we want the rate. So that's modified by delta time. And I'm going to use the your rate. Could have called it bank value, but whatever. And I'll set up those values a bit more in a bit. Let's just test that quickly. Your rate. So we're leaning left, right. We're leaning left, right. Okay. So the node is working. I'm going to change the max lean to 10, so it can't be too extreme. There we go. That's a bit better. We'll save that. So the node is set up. The node is really simple to set up. Let's go to our event graph now, and we need to set up that your delta. All right, let's find our current your rate or your delta so that we can inform our banking. So that's going to be here. We'll set that one, we'll keep that there for later. And we're going to need our actor. Let's drag a pin from here. I'm going to say get actor rotation. And we're going to want to have the delta rotator. That's right. I'll actually chuck it in there because we're delta rotating from the last rotation. So I actually made a variable, a rotator called the last rotation. And we'll throw that in here. So the difference in rotator and rotation between the last tick and the current. So we're going to take that and we're going to break that. And we're only after the Z, the up vector rotation. And that is going to be our delta. However, we need to divide it by delta time. And our delta time is going to come from here. To get our actual rate. Otherwise, we've just got a your delta. Now, we probably want to smooth this out, but I'm going to leave it just for now. We'll set our your rate. And then what we'll do is we will set our last rotation. There. Now, obviously, I'm calling this multiple times and it's a bit silly, but whatever. That's Blueprint for you. So we're setting our last rotation at the end there. That is all well and good. Let me just check. Divide by delta time. That seems good to me. Now, it's probably going to be very, very jittery. Let's try this out quickly. Yeah. So, as I thought. This is going to be really jittery. And it's leaning in the wrong direction. So let's fix that. I mean, it's doing what it says on the tin. So when I do change the direction, it's working, but let's multiply by -1, multiply by -1. Okay, and yeah, we might want to do a smooth there, but let's first try and do that all within the node itself, and then it'll all be nicely embedded. Go to the run, bank warp, smoothing. Let's set a smooth of 50. Give that a go. There we go, it's getting a little bit better. But we need to set our actual parameters because you can see how it's kind of locked. So let's actually watch this value, go to our debug and watch the value and see what kind of is the max value that we're going to find. Where is it? Okay, there we go. Oh, I need to watch the right character, sorry. So it's getting up to almost like 360 sometimes at tops. Let's say that when it gets to 270, that's a maximum lean, because that's pretty quick. It's a pretty fast lean. So 270, so max twist, so 30 max. So we need to do a few things. So 10 divided by 270. Actually, I'm going to do 180. Is going to be 0.055. And then for our other one, so 30 divided by 180, 0.167. Okay. You can see because I'm twisting at a rate per unit of whatever that your value is. I'll unwatch that. And we can go back to our game. And here we get it. It's a bit subtle now. It is working. But we also only want it to work when it's sprinting. So let's go back to our event graph. And we will say, we'll do a branch. And our condition is, oh, this is going to get messy now. Speed is greater than 600, 601. Then we will set the yaw rate like that. Otherwise, we are going to simply set the yaw rate to 0. Save it's a bit of a hack, to be honest. It's not very nice, but let's go in here. So now nothing happens, but when we sprint, we should get our lean. So we're getting a twist. I'd say it could be a little bit better. We could do a little bit more banking here. So let's make our lean rate, let's double them. So let's say 0.11, and this will be like 0.35. So shift, sprinting, there we go. There's a bit more leaning going on there. Still a bit slow. Let's smooth that out. Let's make it a bit faster. Maybe 150. Give that a try. I should stop. I should just change it at runtime. I don't know why I keep coming out of it. There we go. Oof. So that's kind of working. You still need to play with it to get it right. Probably needs to be even faster. So I'm going to say 250. Okay, that's getting there. And remember, we're pretending that we're not strafing while we're sprinting. I don't want to go through the whole thing of making that state. That's a bit too unspecific. But you can see here that with very few animations, we've got maybe 5 animations. We've actually got a lot of final animation here. And we could go a step further. We could add jumps and all that, but that's not really important. The important thing is showing you here how the Strider nodes work. And yeah, so I'm gonna time lapse now, adding in a walk animation set for this and a walk state. So if you want to watch that, you can watch it. It's going to be pretty much the same setup. In fact, I'm going to copy and paste the entire run state graph and chuck it in there. But yeah, otherwise, enjoy. Thank you for watching. I hope this asset can help you. Obviously, take this to the next level and go a step further with it. And yeah, all right, let's get to it. Okay, there we have it. I've just about done with this animation graph. I've added in walking. Obviously there's way more you could add to it. Things like plants and stuff if you had those animations. Unfortunately, that's a different kettle of fish. The plants done in, say, Paragon was done with distance warping, which is out of scope for Strider. Strider is about changing your character's pose. So we're not going to tackle that in this video. And but you can see now we have the walking, and it's slow, and then it gets bigger, and then it progresses into running. And that all works the exact same way with our stride warp node, with our slope warp node, with our and with our orientation warp node. I've taken banking and acceleration warping out of the animation graph for walking. So I mean, basically I've just got a conduit here, and I'm going to running or walking depending on the speed now. So speed is over 400, and you can see the walking, it's set up in the exact same way with different animations. In fact, I copied the whole thing over and just changed those animations, and I removed the bank and acceleration warping for walking because it doesn't really make sense. What I did have to change is, you'll notice I'm still using play rate and relative direction here, and the reason it still works is because what I did was I went into all these clips and I added curves. There's probably a better way to do this, but this was just a quick fix. Is I added curves that were just flat lines at the speed that the animation was moving. This is really helpful, especially if you've got animations that are accelerating. You can make a curve of that acceleration speed. You could even write something that will create that curve automatically for you by extracting the root motion and calculating that speed. It's better than doing the extracting the root motion at runtime. It'll be more efficient. So you'll see here, I've just gone through and I made these curves, and you can see I've just set it to 300, and in the run I've set them to 600. It's probably a better way to do this, especially since it's just a flat line. However, it's probably, if you've got accelerations and decelerations, then the 600 is probably, I mean, the curve is the best option. Then if we go to our event graph, instead of setting a flat value for, where is it? Here, when we're finding out our play rate, so our total speed scale, we had speed divided by 600, but now we have speed divided by whatever the curve is there. And that's why it still works when we're walking. So you'd find that if you didn't do that, even at like a full walking speed, our character would still look like do this sort of tiny little animation. But now it seems more reasonable. There's no foot sliding. I can't see any. And I've even made it so that the walk can get scaled beyond its normal one. So I've set the section where it changes from walking to running to be 400, above 400 speed, instead of at what the walk speed is, so it can scale out a bit more. And you can see all that. Of course, if you had things like transitions, like slowing down or running or speeding up, that would be even better. And, you know, setting up sync markers and all that. But that's out of scope for this tutorial. You get the idea. So that's pretty much it. Let me have a quick look if there was anything else I did. No, that was it. That was everything I changed. Thank you all for watching. I hope you've learned how you can use Strider now to create quite a complex animation system. And if you keep going down this line of using the orientation warping nodes and setting up more states, you can come up with a very complex, really good looking animation system with very few animations. Add in a few other techniques and a few other tools from other systems, and you'll be all good. Thank you all for watching. This is the last tutorial for Strider for Unreal Engine 4. I'll see you around.